question 1a, we need to convert the nominal interest rate to the effective and vice versa. So the question is given the nominal rate is 12% compounded monthly. Find the effective. So we know that nominal is 12 and C over Y is 12 because compounded monthly. So to find the effective, we need to press second and then 2, I convert. So the nominal is 12 and then we enter and then press up, so CY. So C over Y is 12, enter, and then we found effective. So we compute, then we get 12.6825. So we already know that the effective is 12.6825. We want to find the nominal. So we press second and then 2, I convert. So we want to find nominal. So we press up to C over Y is 12 and then enter. And then the effective is 12.6825, enter. And then the nominal we compute and then we get 12. So for question 1b1, we need to find the present value and the future value for immediate annuity, which means that pay at the end of the period. So we need to set our calculator into END. So let's say that our calculator has the BGN. So we need to press second, PMT, payment, second, and enter to set to END. So for the question, calculate the present value of 300 paid at the end of each year for 20 years using an annual effective interest of 8%. So we know N is 20, payment is negative 300, and interest is 8. So we need to find the present value. So 20 N, and then negative 300 for payment, 8 for interest, and then we compute the present value, and then we get 2945.4442. Next, we need to find the future value for immediate annuity. So the question is calculate the future value of an annuity immediate of amount 100 paid annually for 5 years at the rate of interest 9%. So N5, payment negative 100, interest 9, and then we need to find the future value. So 5N, and then negative 100 payment, 9 for interest, and then we compute the future value. We got 598.4711. For question 1b2, we need to find the present value and the future value for annuity due. So in order to find annuity due, we need to set the calculator into the BGN mode. Because annuity due is paid at the beginning of the period, so we press second and then PMT, second and enter, so BGN. So the first question is a 5-year annuity due has credit cash flow of 100 each year. Find the present value of this annuity if the effective annual rate is 8%. So 5 is the year end, and then negative 100 is the payment, 8 is the interest, and then we compute present value. So we get 431.2127 for the future value of annuity due. So the question is what amount we accumulate if we deposit 5,000 at the beginning of each year for the next 5 years. So 6% interest compounded annually. So the beginning of each year means annuity due. So we know the N is 5, payment is negative 5,000, interest is 6, and we need to find the future value. So we have set the calculator into the BGN. So 5N, and then negative 5,000 is the payment, and then 6 is the interest, and then we compute the future value. So we get 2987.6.5927.
Go to the first example, which we want to find the present value of increasing annuity, which N equal to 20 and interest equal to 8%. First, we must put our calculator in the begin mode. First, we press second, and then we press begin. Next is second, and then set. And then we can quit second, press quit. Next, we need to make sure that our PY and CY equals to 1. So we press second, PY, we press 1 and enter. Then we press the down button and press 1 for the CY value and press enter. Then we can quit second, press quit. Our N is 20, so we press 20, and our interest is 8, so we press 8 IY. Our PV is what we want to find. Our payment is 1 negative payment because we pay. Our future value is 20, so 20 FV. Then we press compute PV. Then we get the answer 6.3126. Second example, Mr. Malik is retiring tomorrow and he expects to live another 20 years. He already had an amount of money in his account and he wants to start making annual withdrawals tomorrow at that amount of money. The account is estimated to earn 5% annually and he wants to increase his withdrawals by 3% every year. How much money does he already have in his account? So our N is 20 and this amount is our payment. We have to find the interest using this formula. The interest rate is 0.05, growth rate is 0.03. We plug in into the formula and we get interest equal to 1.9417. We need to make sure that our calculator is in the begin mode. Then we can press 20 and our IY is 1.9417 and 59654.86544 is our payment. It is supposed to be positive because it is a withdrawal. Then we put 0 as our future value. Then we press compute PV, which is we get 1 million. For example, Mr. Malik will retire another 40 years. He wants to save 10k in his account at the end of the year. The account is estimated to earn 10% annually and he wants to increase investment by 4% every year. How much amount of money will he have in his account after 40 years? So we have 10k as a capital and interest equal to 10%. We need to find the future value, but we don't have present value, so we need to find the present value first using the formula. As far as I know, when we don't have both present value and future value, we cannot calculate them on the calculator. So we need to find the present value first using the formula. So we just plug in into the formula. C is capital, R is interest rate 0.1, G is growth rate 0.04. So we just plug in everything and we get this value as a present value. So again, make sure to put our calculator in the begin mode. So our n is 40, so we press 40, and our interest is 10, so 10 IY. Then press 148,986.96567 and press PV. Since we don't have any payment value, so we press 0 and press payment, then we press compute and FV, then we get 6743039.152 as future value. First example for annuity payable PLI. On the basis of an interest rate 12% per annum effective, find the present value of annuity of 600 per annum for 20 years payable quarterly and monthly in arrears. So for quarterly, the interest rate is 12%, the payment is 600 divided by 4 because we have 4 payments in a year because it's payable quarterly. And our N is 20 times 4 because 20 years times 4 payments per year. So we have N equal to 80. So press second PY. Our PY is 4 because it is payable quarterly and press enter. Then press down button. Our CY is 1 because it is compounded yearly per annum. Press enter. Then we can quit second quit. Our N is 80, so we press 80 N. Our interest is 12, so we press 12 IY. Our payment is we press 600 divide by 4 and press equal. Then only we press payment. We don't have future value, so 0 FV. Then compute PV, so we get the answer for PV. For monthly, the I is still 12. The payment is 600 divided by 12 because the payment is made every month. Our N is 240 because we have 20 years times 12 payments per year. So we need to find the present value. First we press second PY. Our PY is 12 because payable monthly. Press enter, down button. Our CY is 1 because per annum. Enter, and then we can quit second quit. Next we press 12 IY because our interest is 12. Our N is 240, so 240 N. Then we press 600 divided by 12, press equal, and then press payment. Since we don't have future value, so 0 FV. Then we press compute PV, so we get the answer for present value. Second example, what is the future value of 600 invested at 80% per annum payable semi-annually for 4 years and 6 months? Our N is 4.5 times 2 because 4 years and 6 months equal to 4.5 years times 2 because it is payable semi-annually, meaning that there are 2 payments in a year. Our I is 8%. Our present value is 600 because 600 is invested. So we need to find the future value. Press second PY equals to 2 because payable semi-annually. Press enter. Press down button. CY also 2. Then press enter. Second quit. Our N is 9, so 9 N. Our interest is 8, so 8 IY. Present value 600. PV, we don't have any payment, so 0 payment. We press compute FV, so we get the future value.
Okay, so for question 1C, we will provide with 3 tips. The first one is, if we press 2 plus 3, but we want to delete the 3, we want to add 2 to 5, we can just click clear and then click 5 and then we get 7, which is 2 plus 5. But if we want to clear all, which means 2 plus 3, but we want to change it to 3 plus 7, we can just click this button twice and then click the new one, 3 plus 7, which equals to 10. Second tips is, this is 2 decimal point and we want to change it to 4 decimal point. So we can just click second dot 4 and then click enter. Simple, right? For the third tips, make sure to set your calculator to the correct mode. For example, if you want to find the annuity due, please make sure that your calculator is in beginning mode, which you can just press second button, pick empty, and then plus second again, and press enter. So it's in BGM mode.
For question 2A, the question wants to be a template for the interchange of I, I2, I4, I12, D2, D4, D12, and delta. So from the formula of IP, dp, and delta, we can see that the value can be found if there is the value of I. So first, if we don't have the value of I, we need to find the value of I first. So if it's given the value of IP, we can use this formula to find the value of I by substitute the amount of IP and P. If it's given the value of dp, we can use these two formula to find the value of I. And if it's given the value of delta, we can use this formula to find the value of I. And if it's given value of d, we can use this formula to find the value of I. So when we have the value of I, now we can use it to build a table to find the value of IP, dp, and delta by using the value of I. To find the value of IP, we can use this formula to find the value. So just substitute the value of I and P. So 1 plus I 12 of 1 over P minus 1 times P. So need to make sure that the I is fixed at H8. So need to make sure to put the dollar sign. And the P is also fixed at column G. So also put the dollar sign in front and enter. And then we drag it from P1 to P12 to find the value of I1 up to I12. So same goes to dp. We use these two formula to find the value of dp. So 1 plus I to the power of negative 1 over p minus 1 times p and multiply by negative. And also same goes, we need to make sure that the value of I is fixed at H8. So dollar sign, same goes to the value of P fixed at row G. So also need to put the dollar sign, enter, and we drag to find the value of D1 up to D12. To find the value of delta, we can use the formula and substitute the value of I. So ln 1 plus I. So we can find the value of d delta I2, I2, D2, I4, D4, I12, and D12. So if we don't have the value of I and it's given IP, we can just equal it to the value of I we found earlier, equal, and we can find the value of IP, DP, and delta.
Hi, my name is Alia Shaira. I'm going to present question 2 for immediate annuity. So first, we can fill in the interest from 0.01 until 0.5 with the step size of 0.001. So we type in 0.01 and then 0.011 and then we select them both. And when the cursor change into a plus symbol, we can drag it all the way until it becomes 0.5. So we don't have to fill in one by one from 0.01 until 0.5. We can just drag it all the way. And then for the immediate annuity, we fill in the formula for immediate annuity, which is 1 minus v to the power of n divided by I. But since we don't have the v for this question, we use 1 minus 1 plus I to the power of negative n divided by I. So we type equal. Don't forget to put equal to indicate that it's a formula. So 1 minus 1 plus I. So for this I, we want to use 0.01 and it's on the cell A6. So we type in A6 to the power of negative 3. So we let n equal to 3 for this question. And then divided by I, which is A6. And we type enter. And then we got the immediate annuity for the interest 0.01, and then we drag it all the way until the interest 0.5, and then we can see that we get the immediate annuity for every interest correspond to the interest that we have assigned it. So to make a diagram for this immediate annuity as the interest increases, we select them all until the 0.5 interest, and then we click insert, we click recommended chart. So we could choose which chart that suitable for this type of diagram. So and then we click OK, and then we can get a diagram for the immediate annuity as the I changes. So next, for the immediate annuity as the N changes, first we fill in the N from 1 until 30 like before, so 1 and 2, and then we drag it all the way until 30, drag it all the way. And then for the immediate annuity, we plug in 1 minus 1 plus I. For this question, we let I equal to 0.1 minus 1 plus I to the power of negative n. And n for this example, n is 1 on the cell N6. So we type in N6 divided by 0.1, and then we press enter, and then we get the value of immediate annuity. And then we drag it all the way until 30, until n equal to 30. And then we can see that for each n, the n in the formula for immediate annuity correspond to the n that we have assigned it to be. So to make a diagram as the n changes, you select them all, and then we click insert, we click recommended chart, and then we pick any chart that is suitable, and then we can get a diagram for the immediate annuity as the n changes. So that's all from me. Thank you.
Hi, I am Nur Izzati binti Zulkifli from Group A4. I'm going to present question 2b2, where question 2b2 is to analyze annuity due to be a function on I, where I increases from 0.01 to 0.5 with a step size of 0.001. And also we need to analyze annuity due to be a function on n, where n increases from 1 to 30 years. So for function of I, which means I changes, we need to list out I equals to 0.01 until 0.5. We changes between them is 0.001. So it will be a lot work to do to list it manually. So we can just write it first, 0.01 here, and then we choose this fill function, and then we choose the series, and then we choose column since we want it to be listed downwards, and then the step value is 0.001, and then for the stop value is 0.5, and then we can press OK, and then we will get all the list of number. For annuity due, to get it is we need to key in the formula into the formula bar. So this is the original formula. Annuity due, or A double dot angle n, is equals to 1 minus V to the power of n over d. But since V and d is not provided to us, so we need to change V and d in terms of I. So the formula become 1 plus I times 1 minus 1 plus I to the power of negative n over I. So the n value, I choose n equals to 2 because from definition, annuity due, the n must be greater than or equal to 2. So I just take the smallest value, which is 2. And then we just need to key in the formula. Remember to put equal sign before any formula. And then just for the value of I, every value of I here, we just click this cell A3 to replace the value of I. And then after finishing key in the formula, we can just press enter, and we will get this value. And then for the value below, we do not need to calculate it one by one. We just need to go at the right bottom corner here, and then we can see the plus sign. We just click here, and then we drag it until the last value of I, which is 0.5, to get all of the value. And then for the graph, we can do it like this. We just need to highlight from here until the last one, and then we click insert, and then we click recommended charts. Also, we can choose any charts from here, but I choose recommended charts, and then they give me this line graph. And this graph show that for increasing I from 0.01 until 0.5, annuity due decrease from near 2 until near 1.65. Okay, then for annuity due in function of n where n changes, we want to change the n from 1 until 30. So we can list it manually or also list it like before, which is this fill function. And then for annuity due, we use the same formula also, but now we let I to be constant, which is I choose 0.05 as the value of I. And then this now n is changing, right? So for the value of n, I click this cell L3 and then just press enter after all this formula is finished, key in. And then as before also we click here and drag it until 30 to get all this value. For the graph also highlight all of this and click insert, click this recommended charts of any or any charts from here, and then we get this beautiful graph. As n increases from 1 until 30, NVDU also increases from 1 until 16. So that's all from me. Thank you.
Hello doctor, my name is Siti Maisara. Today I will present to you about question 2b3 for increasing annuity. So for the first part, we change the I from 0.01 until 0.5 in step size of 0.001. So I listed down all the I and then I will calculate the increasing annuity. Okay, so I let n to be equal to 3. So we know that if we want to calculate the increasing annuity in the formula, we need to find the annuity due first. So I find the annuity due using this formula 1 minus v power of n, but I change v into 1 plus I because we have I here, power of negative n, negative 3 times with 1 plus I over I because we divided it by D. So D equals to I over 1 plus I. So after we plug in the formula, we get this number, and then for the bottom numbers, we can just drag it all the way there, and then we get the annuity due for all these I. So when we get the annuity due, we can put in the formula for increasing annuity. So increasing annuity, the formula is annuity due minus with n is 3, v I change to 1 plus I power of negative, and then n divided by I. So I get this number, and then so as before I just drag this cell to the bottom part, and then I will get all this number. So after I get all this number, I can generate this line chart. So here we can clearly see that when I increases from 0.01 until 0.5, the increasing annuity will gradually decrease. Okay, so for the next part, here the I is constant. We let I to be 0.1 and then we change the n from 1 to 30. Okay, so the same process, we find the annuity due first, and then I just plug in the formula. 1.1 is equals to 1 plus I. So the n part here, we just click this cell. After we get the annuity due, after we drag it all the way down and we get all the annuity due, we can just find the increasing annuity using the same formula as before. The annuity due minus n, v is 1 plus I power of negative n divided by 0.1 is the I. So after we can just drag it, and then we get all these numbers, and then we can just generate this line chart. So from this line chart, we can see that when n increases from 1 to 30, the increasing annuity will increase. So that's all from me. Thank you.
Proceed with the question 2b for annuity payable daily. The first one be a function on I for present value immediate annuity and the annuity due. So the immediate annuity is equals to 1 minus v power of n divided by ip, and for annuity due is equals to 1 minus v power of n divided by dp. So we constant our n in p, n is equal to 5, p is equal to 2. So for I we make from 0.01 until 0.5. Then we calculate the value for v power of n from I 0.01 until I equals to 0.5. Next, we calculate the value for IP. We plug in the formula for I0.01 until I equals to 0.5. Next, we calculate the immediate annuity. We use formula 1 minus v power of n divided by IT for I0.01 until I equals to 0.5. Next, we calculate the value for DP. Same, we plug in the formula for I0.01 until 0.5. And the last one, we calculate the value for annuity due. We use 1 minus v power of n divided by dt for I0.01 until 0.5. Then we transfer in the form of graph. Okay. The x-axis is the interest and the y-axis is the present value for purple immediate annuity and the red one for annuity due. So for the graph, you can say as I increase, the present value of Philip annuity due and immediate emitter will decrease. We see decrease from here to here. Okay, next for accumulation, immediate annuity and annuity due. For immediate annuities is equal to 1 plus I power of n times with A in bracket P angles n. And for annuity due is 1 plus I power of n times with A double dot in bracket P angles n. Same, we constant our n is equal to 5 and our P is equals to 2. So we make table for I from 0.01 until 0.5. Then we calculate the formula immediate annuity. We use this formula for I0.01 until 0.5. Next, we calculate the annuity due. We use this formula for I0.01 until I0.5. Then we select all the data and transfer into the graph. Okay, this graph S is for interest and the Y axis is accumulation value for the green one, immediate annuity, and the brown one is for annuity due. So from the graph, we can say as I increase, the accumulated amount of Philip immediate annuity and the annuity due are increased. Okay. Next, we proceed with the second one, be a function on n for present value, immediate annuity, and the annuity due. The formula is the same, 1 minus v power of n divided by IP for immediate annuity, and the annuity due is 1 minus v power of n divided by dp. But in this case, we constant our I 0.05 and our P is equals to 2. So we make table n from 1 until 30, and we then calculate the value for v power of n. Next, we calculate the value for immediate annuity. We use this 1 minus v power of n divided by IP for n equals to 1 until n equals to 30. Same goes to annuity due. We use this formula for n equals to 1 until n equals to 30. Then we convert into the graph. Okay, the first graph is for S as years and the Y as for present value, immediate annuity. And the second one for the graph, present value for annuity due. So from the both graph, we can say as n increase, the present value of Philip annuity due and immediate annuity will increase. Okay, next we continue with the last one, the accumulation for immediate annuity and annuity due. For immediate annuity, the formula is same, 1 plus I power of n times with A in bracket P angles n for immediate. And for annuity, is equal to 1 plus I power of n times with A double dot in bracket P angles n. Same, we constant our I 0.05 and our P is equals to 2. We make table, n is equal to 1 until 30. And then we calculate the value for immediate annuity. We use this formula and substitute the n equals to 1 and until n equals to 30. Then we continue with calculating the annuity due. We use this formula. Then we plug in for n equals to 1 until n equals to 30. Then we transform in the form of graph. Okay, the first graph for years and the accumulation value for immediate annuity. And the second one is graph of years and the accumulation value for annuity due. So as we can see, the both graphs show that as the increase of n years, the accumulated amount of Philip immediate annuity and annuity due are increased. That's all for me. Thank you.